Okay, hello everyone. In this video, we are going to discuss Fourier sine and cosine transform and its corresponding numerical. Last class, we have been discussed in detail about Fourier transform in 3 dimension and Fourier transform of 3D Gaussian wave function. In this class, we are going to discuss Fourier sine and cosine transform. First, we are going to start to discuss about Fourier sine transform. In short, it is written as f dot s dot t. Okay. Previously we know Fourier sine integral of a function f of x, small f of x, is this much. Here you can see. Previously you can check, maybe after this video you can check after Fourier integral theorem video. After this video, here Fourier sine and cosine integrals. Here Fourier sine and cosine integral, this is called Fourier sine integral. Here 1 by pi 0 to infinity sine omega x d omega minus infinity to plus infinity f of t sine omega t dt. Okay, so here you can see ft is the odd function, sine omega t itself odd function. So by multiplied with odd function with sine, this is a even function. So if it is even function, this limit can be considered as 2 into 0 to infinity, what I written over here. Okay, 2 into 0 to infinity, so 2 by pi. Here you can see it is written as 1 by pi 0 to infinity minus infinity to infinity, but here I written 2 by pi 0 to infinity sine omega x d omega. Here sine omega x d omega 0 to infinity I written there. Okay, 0 to infinity f of t sine omega t dt. Okay, so that implies f of x can be written as 1 by 2 pi root over this integral into 1 by 2 pi root over this integral, and this integral of this equation number 1 is called as your Fourier sine integral. So let this is your equation number 1, and from equation number 1 you can see that if I am going to integrate, then with respect to t, then omega considered as constant. So finally we can get a function which will be the function of omega, because after integrating with respect to d, by substituting the upper and lower limit, we can found the function which will be the function of omega only. So this integral value, whatever the result we can found, suppose that is your from capital F subscript s function of omega. Okay, so this is so called your Fourier sine transform of f of t, small f of t. So this capital F s omega, which is your integral 2 by pi root over 0 to infinity f of t sine omega t dt, sine omega dt, represents Fourier sine transform. Fourier sine transform f s omega means Fourier sine transform of f t, or we can write Fourier f dot s dot t of f of t is your capital F s omega. Okay, so you just remember this integral which is called as the Fourier sine transform of this one, which transformed t domain to omega domain. Okay, now if we are going to consider equation number 1 by substituting this value, then this equation number 1 will be fx will be equal to 2 by pi root over 0 to infinity. Here we have to substitute this value fs omega sine omega x d omega, and here x is your dummy symbol. So instead of x, if we are going to put t, then equation number 3 will be written as f of t, small f of t, equal to 2 by pi root over 0 to infinity f s omega sine omega t dt. So here f small f t will be called as your inverse Fourier sine transform of capital F s omega. So same thing, it has been written that the equation number 4 represents the inverse Fourier sine transform of this f s omega, or in short we can write inverse Fourier sine transform I dot f dot s dot t of f s omega is your small f of t. Likewise, we can write the Fourier cosine transform and its inverse Fourier cosine transform of the function. In general, Fourier cosine integral of the function f of x, what it has been written, 1 by 2 pi 0 1 by pi 0 to infinity cos omega x d omega minus infinity plus infinity. Here ft is your even function, cos omega t also even. So this function is itself a even. So if it is even function, instead of minus infinity to plus infinity, we can write 2 into 0 to infinity, right? What I have been written over here. In general, we know in general Fourier cosine integral of a function f of x, small f of x, is 2 by pi 0 to infinity cos omega x d omega, and here if I multiply 2, this will be 0 to 2. Okay, so, sorry, 0 to infinity. Okay, minus into plus infinity will be converted to 2 into 0 to infinity. So here 2 into 0 to infinity integration f of t cos omega t dt. Similarly, this integral will be called as Fourier cosine transform. So Fourier cosine transform of this f of t, or symbolically written as f subscript c omega, is your this integration, and 2 by pi root over will be multiplied. Okay, here how we written 2 by pi written as 2 by pi root over 2 by pi root over. So similarly 2 by pi root over 0 to infinity f of t cos omega t dt is nothing but Fourier cosine transform of this f of t to fc omega. Corresponding inverse Fourier cosine transform of this function fc omega is nothing but f of t, small f of t, okay, will be equal to 1, so 2 by pi root over 0 to infinity this function fc omega cos omega t d omega. So here integration with respect to t, here integration with respect to omega. Here same thing. Fourier sine transform of a function f of t means f of t into sine omega t dt. Corresponding inverse Fourier transform is your fs omega sine omega t d omega. That means integration with respect to d omega. Okay, so you just remember these 4 integrals. This one, equation number 2, 4, and this is your equation number 5, suppose 5 and 6. Fourier cosine transform and inverse Fourier cosine transform. Now we are going to go for its corresponding numericals. So the given function is your e to the power minus at. We have to find out the Fourier sine and cosine transform. In general, Fourier sine transform of a function f of t, which is written as fs of f of t or fs omega, is equal to 2 by pi root over 0 to infinity f of t sine omega t dt, what we have been discussed over here. Okay, this one. Okay, so in the question, f of t is your e to the power minus t, just substituted here instead of f of t, and the integration value of e to the power minus t into sine omega d dt will be this one. I told initially some important integrals that you have to remember here. Here e to the power ax sine bx dx is your e to the ax by a square plus b square. Here instead of e to the ax, here e to the a t sine omega t, instead of b omega is there, so e to the power minus a t. Here minus a square plus b square means omega square, minus a square is itself a square. Then a sine bx, here a means minus a sine bx means omega t minus b cos bx, b means omega cos bx means omega t, and limit is your 0 to infinity. So first we have to put the upper limit. If I will be put to minus infinity, e to the minus infinity is 0, so entire term will be 0, minus we have to put 0, e to the 0 is 1 by a square plus omega square. Here if I will be put 0, this term will be 0, and here if I will be put instead of t will be 0, then cos 0 is 1, so we can found minus omega, here minus plus, finally you can get the answer 2 by pi root over omega by omega square plus a square is the answer. That is your Fourier sine transform of this e to the power minus at function. Now we are going to go for Fourier cosine transform of this function. In general, Fourier cosine transform of a function f of t or fc f of t or fc omega is written as 2 by pi root over 0 to infinity f of t cos omega t dt. Instead of f of t, we have to write e to the power minus at cos omega t dt. So I told that you have to remember this integration, that e to the power minus ax into cos bx dx is your e to the ax by a square plus b square into a into cos bx plus b sin bx, same thing we have been written over here. So here e to the power a means minus a, b means omega, so e to the power minus at by a square means minus a square itself, a square plus b square means omega square, and here this one is a cos bx, a means minus a cos omega x here t minus a cos omega t plus omega sin omega t, b sin bt means omega sin omega t. 0 to infinity is your limit. First put upper limit. If I will put upper limit instead of t infinity, then this term, whole term will be 0. Then we are going to substitute lower limit. Lower limit means here if I will put 0, e to the 0 is 1 by a square plus omega square, or you can write omega square plus a square, and put 0 over here t. That means it will be 1 and this will be 0. If I will put t equal to 0, sin 0 is 0. So this value will be minus a. So minus plus. So finally we got the answer 2 by pi root over a by omega square plus a square is your answer. You just keep in your mind, is very important, that Fourier cosine transform, a sine transform of e to the minus at is your 2 by pi root over omega by omega square plus a square. Cosine transform is your a by omega square plus a square. 2 by pi root over is common. Find the Fourier cosine transform. Next question. The question is f of x equal to 5 e to the minus 2x plus 2 e to the minus 5x. So Fourier cosine transform we have to find out. Fourier cosine transform of a function is your 2 by pi root over 0 to infinity that function into cos omega x dx. So here two functions, plus is there, so two integral will be there. So 2 by pi root over 0 to infinity 5 e to the minus 2x cos omega x dx. And for this one, 2 into e to the minus 5x cos omega x dx, 2 by pi root over will be there, right? So here 5 constant taken outside, 2 constant taken outside, 0 to infinity e to the minus 2x cos omega x dx, 0 to infinity e to the minus 5x cos omega x dx. If I will consider this integral is nothing but e to the minus 80, whatever we done in our last question, that is e to the minus 80. So e to the minus 80, here a is your minus 2. We are going to find out the cosine transform. For the cosine transform, this is your 2 by pi root over a by omega square plus a square. So here a is how much? A is your 2. Here a is your 2. Okay. Here in general a is a, but instead of a, here a is your 2. So what will the answer if I will compare with the previous question? 2 by pi root over into 5. This is the these two terms are outside of this integration. So this integration value will be 2 by omega square plus 2 square, that means 4. Right? If I will compare, see, if I will compare this integral with this one, with this integral, both are same, but instead of a, there it has been written as 2. If I will compare this integral with this one, instead of a, 5 is written. So what will be the value of this integral? 5 by omega square plus 5 square is your 5. See, here I given a arrow mark. That means if in your exam it asked, this question asked, you should not write this direct answer. You have to find out at least one integral. Similarly, this integral you can write, but you should not write directly this value. Here I written because previously we just done the answer of this question. So by referring the answer of this question, I written, but here I put the arrow mark because you have to derive any one of the integral, then you can write another answer. Okay, you just derive this integral and you can write the answer of this integral, or this integral you can write this answer of this integral. Okay. So here we found that 2 by pi root over 5 into 2, here 2 by pi root over 2 into 5. So this is 2 into 5, 10. So 10 into 2 by pi root over, here this will be 1 by omega square plus 4, 5 by, see, if I will consider 2 into 5, 10 only taken, so this will be 1 by omega square plus 25. This will be the answer of this question. Next we are going to go for the third question, that using, this is important question, this is very important question, 6 mark question. Okay, using Fourier cosine and sine transform of fx equal to e to the power minus ax, find out the integral value, that is 0 to infinity cos omega x by omega square plus a square into d omega, and 0 to infinity omega into sine omega x by omega square plus a square d omega. So we have to use the Fourier cosine sine transform of this function, and we have to find out these two integral. So first we have to derive, or we have to write we have to find out the Fourier sine and cosine transform of this function. Previously we know that the Fourier cosine transform of e to the minus ax equal to this much. Already we done and we written here. Suppose this question has been asked, you have to find out the Fourier sine and cosine transform of this function. What we done here? Okay, what we done here, this much derivation you have to do, otherwise 6 marks you are not going to find, you could not found. Okay, so you have to derive the Fourier cosine transform of e to the minus ax. How we have been derived in the question number 1. You have to derive, then you have to write. But as I derived in question number 1, only for that I written the Fourier transform of e to the minus ax will be 2 by pi root over a by omega square plus a square. Inverse Fourier cosine transform of this one is your simple, the original function fx will be equal to inverse Fourier cosine transform of fc omega, that is your 2 by pi root over 0 to infinity fc omega cos omega x d omega. And this fc omega value is how much? 2 by pi root over a by omega square plus a square. I substituted over here, and this fx is nothing but is your given in your question that e to the minus x. So that implies this function e to the minus x will be equal to 2 by pi root over, instead of fc omega I substituted this value into this integration with respect to d omega, right? So that implies here you can see cos omega x by omega square plus a square. This integration with respect to d omega. So a is the constant, can be taken outside and multiplied with this one. So cos omega x by omega square plus a square 0 to infinity integration d omega will be equal to pi by 2 here. 2 by pi root over. So it will be 2 by pi. Okay, if I multiply these two root over terms, so it will be 2 by pi. If I take this side, so it will be pi by 2 here a, that will be 1 by a e to the minus ax, or we found pi by 2a into e to the minus ax is your answer. So one integral value we found. Similarly, we know Fourier sine transform of e to the minus ax equal to 2 by pi root over omega by omega square plus a square. Now if we are going to consider inverse Fourier transform of this one, that is your the function will be fx in IFST, inverse Fourier transform of this one, that is your 2 by pi root over 0 to infinity this, or fs omega sine omega x d omega. So instead of fs omega I substituted this value, this fx given in the question as e to the minus x ax. So that implies 0 to infinity omega sine omega x d omega by omega square a square will be equal to pi by 2 into e to the minus ax. So using Fourier transform of this one, we found this integral and this net. Again, I am telling that if this question 6 mark asked in your exam, you have to find out cosine and sine transform of this function e to the minus ax, what we derived in question number 1. Okay, now we are going to go for question number 4. This is very important question, very important question for the 6 mark. Repeatedly it asked in your exam. Find fx whose Fourier cosine transform is your 2 by pi root over sine a omega by omega. Here Fourier cosine transform given, we have to find out its function fx, we have to find out. Okay, so the solution starts that we know inverse Fourier cosine transform of fc omega is, that is your IFCT of fc omega is your fx equal to 2 by pi root over fc omega cos omega x integration with respect to d omega, a limit, integration limit is your 0 to infinity, right? So here 2 by pi root over, and fc omega in the question has been given as this one, just substituted over here cos omega x into d omega. So here 2 by pi root over that is your 2 by pi 0 to infinity sine a omega by omega cos omega x into d omega, right, is equal to 2 by pi. Here I multiplied 2, here I multiplied 2 and divided 2. So 1 by 2 here what? It will be 2 sine a omega cos omega x. That means it is in the form of 2 sine c and sine d. We know 2 sine c or d or 2 sine a into cos b. Here you can see sine a omega omega x. So it will be in the form of 2 sine a into cos b. So 2 sine a into cos b formula is nothing but sine a plus b plus sine a minus b. So same thing you have to write. So here 1 by 2, 2 by pi, 1 by 2. Here I written 2 sine a omega into cos omega x will be written as sine this one, this plus this, a omega plus omega x. Omega can be taken outside, omega into a plus x, this a omega minus omega x, sine omega into a minus x, d omega whole divided by omega is there, I written over here, right? Okay, now that implies this fx will be equal to here 2 got cancel. We can found 1 by pi 0 to infinity sine omega ax a plus x by omega one term d omega plus 1 by pi 0 to infinity sine omega a minus x by omega d omega another term. Okay, now what will be the value of this integral? Carefully you have to watch now. Here I told that this is a special integral that you have to remember. Here you can see sine ax by x into dx 0 to infinity, the value is pi by 2. That means here what is the value is here 0 to infinity sin ax by x dx value is your pi by 2. The condition is that a, when a is your greater than 0, when a is your positive, this value is pi by 2. And if a is negative, suppose if we are going to consider a is less than 0, a negative means sine is a negative function. So if a is less than 0 or negative, then this value will be minus pi by 2. Okay, now we are going to use this special integration over here. Here you can see, if I am going to compare this two integral, carefully you have to watch. Here sine a plus x act as constant, here a is act as constant, x variable, integration with respect to x, here omega variable, integration with respect to omega, and here a is positive, x is positive, so this value is positive, then this whole integration value will be pi by 2. Okay, now consider this one, this integration, if we are going to consider a minus x is positive, then the value will be pi by 2. Okay, here you can see omega here instead of x omega, and instead of a, here it is a minus x, so value will be obviously pi by 2, but the condition is that a minus x should be greater than 0. So if a minus x, this value is greater than 0 or positive, or if a minus x is greater than 0, or we can say x is less than a, then this value is positive and this integral value will be pi by 2. So for x is less than a, fx finally how much we found? Here 1 by pi into pi by 2 plus 1 by pi by 2, pi got cancelled, 1 by 2 plus 1 by 2 is your 1. So for x less than a, the function value is your 1, fx is your 1. Now we are going to consider if a minus x, for this integral a minus is negative, that means less than 0. If it will be less than 0, then the value will be how much? Minus pi by 2, because this sine is a odd function. So this will be 1 by pi, this integration pi by 2, this integration will be minus pi by 2. So if it is so, then this plus and this is minus will be 0. So here if a minus x will be less than 0 or x greater than a, then fx equal to 0. Okay, so fx equal to 0 we found when x greater than a. Finally, systematically we can write fx will be equal to 1 for x less than a, fx equal to 0 for x greater than a. Okay, so this is very important question for your exam point of view for the 6th mark. Okay, so do practice it for your exam. Next we are going to go for question number 5, that we have to solve the integral equation. This one, this is also one of the important question, that 2 by pi root over 0 to infinity fx cos omega x dx is given as 1 by 1 minus omega for omega in between 0 to 1. Okay, 0 for omega greater than 1. And then we have to show that 0 to infinity sine square t, this is sine square t by t square dt equal to pi by t. Okay, so this is the detailed derivation of this question. Let's start. We know the Fourier cosine transform of a function fx is written at f dot c dot t of fx or fc omega is your 2 by pi root over 0 to infinity fx cos omega x dx is equal to that is your 1 minus omega for omega in between 0 to 1 and 0 for omega greater than 1. So this is nothing but the Fourier cosine transform of a function. Okay, so Fourier cosine transform of a function given in the question. Value will be this one in between 0 to 1, 0 for omega greater than 1. Now consider inverse Fourier cosine transform of this one, fc omega. So inverse Fourier cosine transform of fc omega, which will be how much? fx will be equal to 2 by pi root over 0 to infinity this function fc omega into cos omega x integration with respect to d omega, right? So here the in your here in your question it has been given that the value have two different values in two different limits. So this 0 to infinity whatever we have in general limit, we have to segregate it. Then we can put these two values. So first we have to segregate 0 to 1. This 0 to infinity is segregated from 0 to 1, then 1 to infinity, right? So 0 to 1, here you can see in between 0 to 1, what is the value of this integral or fc omega or Fourier transform of fx? Value is 1 minus omega. So instead of fc omega in between 0 to 1, the value is how much? 1 minus omega. 1 minus omega I have been substituted. Again above 1, that means in between 1 to infinity limit, this value is 0. I have been substituted 0, so this entire integration will be 0. right? Then this is 1 minus omega. Then now we are going to simple integrate it. Simple integrate it. This is your first function, this is your second function. So just do the by parts. The first function as such, it has been written, that is 1 minus omega cos omega x integration with respect to omega is your sin omega x by x. Then minus derivative of 1 minus omega is your minus omega. Okay, this is minus is there, so minus 1, sorry, minus 1, and integration of double integration of this one. So first integration of cos omega x is your sin omega x by x, whatever written, and another integration as such it will be there. So 0 to 1, 0 to 1 is the limit lower and upper d omega, right? So here we have to put, here you can see one thing, that for this integration, sorry, for this term, if we are going to put upper limit here 1, if I will put 1 minus 1 0, then minus 0 I have to substitute. 0 means here instead of omega, if I will put 0, then sin 0 will be 0. So this term entire will be 0, cancelled out. Then minus will be there. Okay, minus, and this minus will be plus, but this integration you just watch. This is sin omega x by omega x. So sin omega x integration is your minus cos omega x by x. So minus cos omega by x, already x is there, so x square. So limit is your 0 to 1, we have to write 0 to 1. Now you just put first upper limit here, omega, this is your minus cos x by x square, then minus 0 instead of omega, cos 0 is your 1 by x square, so minus is there, so minus of minus it will be plus. Okay, so we found 2 by pi root over is there, 2 by pi root over. So this value will be, after substituting the limits, 1. If I put 1, this will be minus cos x by x square, minus of minus 1, minus of minus 1 will be 1 by x square. Okay, so finally we found fx equal to 2 by pi root over 1 minus cos x by x square. Okay, here we found fx value, but we have to find out this one, sin square t by t square dt equal to pi by 2. We have to prove how here, but fc omega, Fourier cosine transform of a function of a function fx is written as 2 by pi root over 0 to infinity fx cos omega x dx, right? This value is nothing but 1 minus omega in between 0 to 1, 0 greater than 1, omega greater than 1. Okay, now 2 by pi root over, and fx value, how much we found? Fx value we found 2 by pi root over 1 minus cos x by x square, that we are going to substitute over here. Just substituted cos omega x dx, value is your 1 minus omega in between 0 to 1, omega in between 0 to 1, 0, omega greater than 1. Okay, now we have to put omega equal to 0. Suppose here in this equation we have to put omega equal to 0, then above equation will be here 2 by pi root over will be 2 by pi 0 to infinity 1 minus cos x by x square, cos x by x square. Here if I will put omega, it will be 0, cos 0 will be how much? Cos 0 will be 1, so cos 0 will be 1, and dx written as such. Here right hand side, if I will put omega equal to 0, then this value will be 1, 0 to infinity, this value will be 1. Got it? Now here 1 minus cos x, 1 minus cos x is nothing but 2 sin square x by 2, x square is there, x square dx, this 2 by pi written this side will be pi by 2. Now let's consider t equal to x by 2, dx equal to 2 into dt. Here limit is not going to be changed, x equal to 0, t also will be 0, x equal to infinity, t also will be infinity. Now we are going to substitute over here. So 0 to infinity 2 sin square, instead of x by 2 it will be t, here x square will be 2t square, here dx will be 2, dt will be pi by 2, and we found 0 to infinity sin square t by t square into dt will be pi by 2. Okay, or we can write here sin square is a even function, it is in the form of square, so t square itself a even function. We can write, if I will multiply 2 and divide 2, if I will multiply 2 divide 2, then this 2 can be written as minus infinity to plus infinity. This 2 will be multiplied with this side RHS, so the value will be pi. So if I will do this, then this can be written as minus infinity plus infinity sin square t by t square dt will be equal to pi. So we need to prove this one, already we have been proved. This one 0 to infinity sin square t by t square dt equal to pi by 2, hence it has been proved. Okay, now we are going to go for our last question, is your Fourier sine transform of the finite wave train. It is written as finite wave train, that is your ft equal to sine omega naught t. Here omega naught is a constant which exists in between t mod less than equal to n pi by omega naught and otherwise 0. So here t mod less than n pi by omega naught. That means this function exists in between minus t to plus t. This is 0, minus t to plus t, this function exists. So t value is here how much? N pi by omega naught minus or plus n pi by omega naught. In between these two values, this function is exist. Otherwise, less than this value and greater than this value is 0. So why it is called, yes, why it is called the wave train, finite wave train? Why it is called finite wave train? See, what is the function it has been given? It is a sinusoidal function. That means whatever the function in between these two values, n pi by omega naught, minus n pi by omega naught, plus n pi by omega naught, the value is your how much? A sine function. Sine function means like this. Okay, like this. So this is a wave, one wave train, but it is finite. Okay, so hence it is called the finite wave train. Okay, now we are going to solve this question. Simple, we have to find out the sine transform. In general, sine transform of a function or that is your fs omega is your 2 by pi root over 0 to infinity that function sine omega t dt. So as the function value is different in between the limits, so we have to segregate it, 0 to t, then t to infinity. Okay, so t to infinity, see 0 to t means from 0 to this t value. In this limit function exists, but f of t there is no function. So as the limit is 0 to infinity, I can segregate 0 to t, to infinity. So in between t to infinity, this function f of t value is 0, so this integral value will be 0. But in this limit, that is your 0 to t, ft value is your sine omega naught t. I just substituted sine omega t already is there into dt, right? So here we found 2 by pi root over 0 to t value is nothing but n pi by omega naught. Here it is given in the question, sine omega naught t into sine omega t dt. And here omega naught is your constant. I have to write omega 0 or naught is your omega naught is your constant. is a constant, right? Okay. So here what I done, I multiplied 1 2 and divided 1 2. If I will multiplied 1 2 here, this will be in the form of 2 sine a into sine b. So 2 sine a into sine b formula is nothing but cos a minus b minus cos a plus b. So this is your a and this is your b. A is your omega t, omega naught t, b is your omega t. That we are going to put this as per this formula. So 1 by 2, already 2 by pi root over is there, 0 to n pi by omega 0. This is your 2 sine omega naught t into sine t will be written as cos. This cos a minus b means this minus this. So t is common, so we can write omega naught minus omega whole into t minus cos a plus b. This plus this. That means omega naught plus omega into t dt. Okay. Now 2 by pi root over 1 by 2 and this integration cos will be sine omega naught minus omega t by this constant omega naught minus omega, because cos integration is always plus sine. Okay. So plus sine omega 0 minus omega t by omega 0 minus omega 0 to limit is your n pi by omega 0. Then minus integration of this one sine omega 0 plus omega t by omega 0 plus omega 0 to n pi by omega. We have to just substitute the values or limits. If I will substitute this one, so n pi omega 0, if I will substitute, the first term will be sine omega 0 minus omega. Instead of t, we have to write n pi by omega 0 minus omega. Then second limit is your, or lower limit, if I will put t equal to 0, then the value will be 0. I not written over here. Then minus this upper limit I have been substituted. If I will do so, then it will be sine omega 0 plus omega minus n omega by omega 0. Then minus, if I will put 0, then the term will be 0. So this will be the answer. Okay. So here we discussed 6 important questions based upon sine and cosine, Fourier sine and cosine transform. So go through these 6 questions and prepare yourself for your exam. If you like this video, please be subscribe and share with your friends. In our next class, we are going to discuss properties of Fourier transform. Okay, so thank you so much for watching this video. Thank you.